Okay, welcome to this video. This is part 2 of the 2012 AEA question that involved integration, differentiation and lots of algebra. Okay, so we've done part 1 where we completed A and B of this question and proved this result. We're now going to do part C. Okay, now in part C we have to show that the ratio of this grey shaded area to the area of this yellow rectangle here is equal to a constant. In other words, it's independent of the values of A and B in this very sort of general question. Now, I've already marked in the lengths, physical lengths A and B, which we were able to deduce from this factorized form of the cubic. And the top of the rectangle is sitting on this turning point S, which is a maximum of that curve. Now this is the expanded, this is the cubic given in factorized form. When you expand it, it's this here. So we know that at S, okay, so for question C, at the point S, the gradient is 0, right? So y dash equals 0, and therefore we've got to differentiate this and set it to 0. Okay, well, if you differentiate that term by term, you get 3x squared. Okay, and remember we're differentiating with respect to x here, so a and b are just numbers, so we get 4bx. Okay, we get plus b squared, then we get plus 2ax, and finally we get minus 2ab. Okay, and the last term here of course just differentiates to 0. Okay, now I'm going to take out a factor of 3. Now the reason I'm doing this is I'm going to have a quadratic, and it's very algebraic, and in order to solve that I best get x on its own, and the way we do that is by completing the square. So if I take out a factor of 3 from the whole thing, okay, it will enable me to do that quite easily. So I get x squared minus 4b, and well, in fact it's if I gather together the like terms, I get there's two x terms there, okay, and they are 2a and 4b minus 4b. So if I do it like this, I get 2a minus 4b, okay, and then that needs dividing by 3 because of the factor I've taken out. That's the x terms, okay, and then I've got my numbers, which are b squared minus 2ab, okay, b squared minus 2ab, and of course they will also need to be over 3 as well, okay, so that gives me that, okay, and because I've taken out that factor of 3, that's got to equal 0, so I can ignore the 3 now at the front, and I've got an expression that begins with x squared, so I can complete the square. All right, so I know that this square bracket has to equal 0, so the x coefficient, if I just put it in its own bracket, it might be a bit clearer. Okay, so that x coefficient has to be halved, so I'm going to have x plus half of that is going to be a minus 2b over 3. Not x, I don't need the x there, do I? So it's that all squared, okay, but that's going to have left over from it an a minus 2b over 3 all squared. Well, that is going to be a squared minus 4ab plus 4b squared. Okay, so that's the residue left over from squaring this last term over 9. Okay, and before I put the line in, I'm going to put this bit on as well, which is b squared minus 2ab, but I'm going to times that by 3, so I can also put that out of 9 as well. Okay, so I've times that part there by 3, so that can also be out of 9. So in fact the whole thing can be put over 9 with a single line now. Okay, so that's just a bit of algebra to try to tidy this up. Okay, now if we take that on to the next stage, we get that, and that has to equal 0, of course. We're setting that to 0 because we're trying to find the value of x, in other words the x coordinate of the turning point S. Okay, because once we found that, we can find the y coordinate and therefore the height of the rectangle. So if we just tidy this up now a little bit, we will find that this second fraction here can be, well, we can put that onto the right hand side and simplify it. We get this. Okay, so we get x plus a minus 2b over 3. Okay, that equals, now it equals this, but simplified actually gives me a squared, okay, plus 2ab, you can easily check this out yourself, plus b squared, okay, and that's all over 9. Now, of course, that result on the top there you should recognize as the perfect square of simply a plus b. So it's a plus b squared. It gives us that, which is very convenient because we will need to to square root that at some point soon. So that should be squared there, of course. Okay, so I need to square root this now, and we know that that will be equal to, let's just write it as the perfect square, a plus b squared over 9. Okay, now if we square root that, of course, we get a plus b over 3. So going back to this, we can say that x plus a minus 2b over 3, okay, so I've taken out the squared sign now, and that must be the square root of this, which remember would be plus or minus a plus b over 3. Okay, now if you just take to get x on its own, we just have to take this to the other side. So x equals plus or minus a plus, well, I can probably be better putting it, oh sorry, I'll leave it like that, a plus b over 2 over 3, okay, minus a minus 2b over 3. Okay, now if you explore that algebra a little bit and just rearrange it, you can get that x equals 3b over 3, which is equal to b. Okay, that's one value of x. Well, we know that because that, of course, corresponds to the minimum point. Or the other value is that x equals b minus 2a over 3. Okay, right, and that's the one that corresponds to S. Now, we need to find out what the y-coordinate is when that happens. Okay, so we need to substitute that value of x into the original expression. So if we go back to here, okay, we got to replace x with that. So y at this point, okay, is going to be b minus 2a over 3, b minus 2a all over 3. That's x plus a, okay, times x minus b all squared. Now, of course, I don't need x in there, do I? I need the actual value of x, which is b minus 2a over 3 minus b all squared. Okay. Now, I'm going to jump a few steps here, okay, because of the time and the space available. But if you work that out very carefully, that expansion, you end up getting that it equals b plus a, okay? So it comes to this after a couple of steps, b plus a times 4a squared plus 8ab plus 4b squared, 4a squared plus 8ab plus 4b squared, okay, which is 4 lots of a plus b squared, and all of that comes over 27. That's a common denominator that's come out of the cubing of this, you see. Okay, you can check all this out, but that's what you get to. And if you take that to one further step, you get that that is equal to a plus b cubed times 4 27ths. Okay, of a plus b all cubed. Now, that's the height of the rectangle, right? So I'm going to have to just move some of this up a bit or go across to here. So the area, I'll go to here. So the area of the rectangle, is equal to this times the length, which of course is a plus b. So it's 4 27ths of a plus b times a plus b cubed, which is a plus b to the 4. Okay, and that's what we're really looking for, because I can now say that the ratio, okay, that I want is g over that, g over the area PQRST is equal to a plus b to the 4 over 12 and all of that is over 4 27ths of a plus b to the 4. Okay, the a plus b to the 4's cancel. Okay, and you're left with 1/12 over, well, it's going to be 1/12 over 4 27ths, which is 1/12 times 27 over 4, okay, which is 27 over 48, which is a number k, and it's irrespective of a and b. And that's it.